Welcome to our session on metals. Metals of various types occur in nature and must be mined and refined to extract the elements and separate them from their impurities. Metals play an important and prominent role in almost every component of our many building projects by virtue of the fact that metals conduct heat and electricity well. Can be formed into many critical components for uses such as structural members, framing members, heating and air conditioning systems, mechanical ties, special components, electrical components, tools and equipment, windows and doors, accessories, furniture, specialized furnishings and equipment, wall and ceiling finishes, signage, building systems, fireplaces, and skylight components. Metals fall broadly under the categories of ferrous metals, which contain iron, and non-ferrous metals. Notice that in this chart that there is a third category of metal, those metals which are alloys of ferrous and non-ferrous metals. An alloy is a metal made up of two or more materials to improve a metal's properties. One of those materials has to be a metal. Ferrous metals are generally stronger than non-ferrous metals, but both types are durable, can be finely crafted, are appropriate for aesthetic purposes, and can be useful components of a building's mechanical, electrical, and plumbing systems by virtue of the fact that metals are malleable and ductile. Unfortunately, when metals exceed their heat limit, they start to deform and melt. Also, with exposure to wet conditions, metals rust, though ferrous metals more so than non-ferrous metals. Non-ferrous metals have their own thin oxide layer which protect them from susceptibility to corrosion. Metals can be expensive because of their scarcity, difficulty to mine, and the cost of labor to manufacture, produce, and install. Several environmental issues associated with mining metals are strip mining, toxicity or poisoning, and carbon emission footprints, which one could consider offset by the high recycling rate of metals. There are a number of ways in which fabricators can join together metal components. This slide shows a method called welding. Welding is high temperature fusing created by a gas flame or electric arc which melts two metals. The point of connection of the two flow together with additional molten metal from a welding rod. Welded connections are as strong as the metals they join and can be used for structural work. Brazing is a lower temperature process. The two metals are not themselves melted, but are joined with the introduction of a third metal with a lower melting point. This forms a connection too weak for structural purposes, but is sufficient for plumbing pipes and roofing. Brazing uses brass or bronze as the third material, while soldering uses a lead-tin alloy. Metals can also be joined by mechanical means, whereby the metals are drilled or punched with holes, through which are inserted rivets, or bolts, or screws. Metals can also be joined by bending them together, such as with a standing seam roof. Methods of fabrication or forming metals are by rolling, bending, extruding or forging, casting, drawing, machining, and stamping. Notice the picture of the stacks of sheeted metal ready to be stamped and embossed by the giant stamping machine into an integrated metal sink top or into diamond embossed plate. The stack of metal sheeting you saw in the previous slide is referred to commonly as sheet metal. Sheet metal thicknesses are expressed in terms of gauge, designated in millimeters, to express the thickness. Unfortunately, gauge refers to an antiquated system of measurement, and so metal manufacturers of steel and aluminum or galvanized steel may have the same gauge, but for different metal thicknesses. That is, there is no strict equation from gauge to mill thickness. The main point to remember is that as the gauge number increases, the sheet thickness becomes thinner. The converse is also true. As the gauge number decreases, the sheet thickness becomes thicker. Let's go on now to discuss some other members of the metal family with which interior designers should be familiar. Cast iron has good compressive strength, but is very brittle, which accounts for why it became discontinued as structural support material, though some fine examples still exist today, particularly in Lower Manhattan's Cast Iron Historic District. Wrought iron is soft and easily crafted. Its high corrosion resistance made it good for use below ground as piping and infrastructure in the early parts of the 20th century. But today, other metals have virtually replaced it. It is used today primarily to fashion ornamental objects. Steel refers to iron formulated with low amounts of carbon to increase strength and is used for structural components, framing members, and structural and mechanical fasteners. When dipped into zinc, steel becomes encapsulated with a protective coating which inhibits rust and is known as galvanized steel. Stainless steel is produced by alloying steel with other metals, primarily chromium or nickel, for superior corrosion resistance, which accounts for its many uses as flashing, fasteners, hardware, and a wide range of finished materials. Used as an alloy with other metals, copper is ductile and corrosion resistant. It has high thermal and electrical conductivity and can be cast, drawn, extruded, or rolled, making it useful for electrical wiring, flashing, roofing, and piping. An alloy of copper and tin, bronze resists corrosion and is used for weather stripping, exterior building cladding, hardware, and ornamental work. Architectural bronze is used mostly for interior finishes, and as you can see from this and the next slide, by its composition, architectural bronze is actually a brass. Brass can be polished to a high luster. Brass doesn't tarnish, but does require constant maintenance. So we're going to look at this in the next few slides to learn about a sampling of other members of the metal family which interior designers frequently encounter. Perhaps you're familiar with pot metals, commonly known as zinc, tin, lead, or pewter. You're probably familiar with gold and gold leaf applications. Silver, or silver leaf. Aluminum. Titanium has been popular for architectural facades in the last 2 decades. Chrome. Metal finishes are specified using jargon developed by the Builders Hardware Manufacturing Association and the American National Standards Institute, ANSI, A-N-S-I. Many experienced interior designers can easily associate the U.S. equivalent finish terminology in this slide with the finish's actual and more common name. Why not learn a few? You see here that by common nomenclature, that for instance satin brass has a designation common in the U.S. as US4. So we may talk to our client about satin brass, but when we specify the material finish, that we want from our hardware supplier, we are going to call it US4. Similarly, bright chrome is US26. Get familiar with this chart and understand that there are two ways to specify a metal finish. One is by its US equivalent number or by its more common proper name. Thank you.